Hi, everybody. Welcome to my channel, Numbers with Nora. This is a math tutoring channel that helps you with all your math needs, questions, homework, and tests. For this specific video, we're going to be doing ACT Math, Section 2.7, Fractions and Ratios. The math book that I'm using is called Ultimate Guide to Math, ACT. Sorry, I put SAT right here. And I'll also put a link where you can sit there and access this book. I think I purchased mine as a PDF on Kindle. And it's a pretty good math book for basic ACT practice test and curriculum. So let's get on with this. First, we'll go through some of the notes and then we'll do some practice questions. So first, the vocabulary that we're going to have is ratios. Ratios are just basically fractions, two ways you can write ratios. And we'll see that later in some of our example problems is basically A, B, or you can write it as a fraction as A over B, where B is not equal to 0. Those are both basically the same things, and we'll sit there and play around with some of these ratio problems as we go on, but that is the definition of a ratio. And then we have adding and subtracting fractions. There are some basic videos out there if you forgot how to add and subtract fractions, but for the ACT, sometimes they want to see you find your least common denominator to see if you can do it quicker. But first, let's sit there and go over how we add these basic fractions. So for this one, the basic way I think of adding fractions, if we're not finding our least common denominators, is we multiply both of our denominators together to get the same common denominator. Okay, and then we cross multiply. So let's do that. For this one, I multiply both my denominators together, 2 times 7, which will give me 14. All right. And then since I have both those the same, then I just literally cross multiply, okay, to get my numerators. So that's 2 times 2, that's going to give me 4. And then I cross multiply this way again. Sometimes I like to call this the butterfly method. 1 times 7, that's 7. Now I have two fractions set up where they're the same denominators. So since it's the same denominators, I can go ahead and just add my numerators or my top numbers. And that's going to give me 7, 8, 9, 10, 11. So my answer is going to be 11 over 14. Okay, we're going to do this one the same way. Okay, and then we'll sit there and look how we do it with finding least common denominator. So for this one, I could sit there and multiply both my denominators together. 15 times 20, that's going to give me 300. 300. And then again, I sit there and use the cross method to sit there and find my numerators and my top numbers. So I multiply 15 times 2. Okay, 15 times 2. That's going to give me 30. And then 7 times 20. Okay, because I'm doing the cross method. 7 times 20, that's going to give me 140. All right. Now that my fractions have the same denominator, I can go ahead and subtract them now. So 140 minus 30, that's going to give me 110 over 300. But I can always simplify this down because 110 and 300. I can cross out one of these zeros, right? And reduce it. So then I would end up with just 11 over 30. Over 30. Okay. And that's subtracting fractions right there. right? And if you need more practice with adding or subtracting fractions, let me know. I can either make a basic video on adding and subtracting fractions or show you like a quick link where it can help you see how to or practice adding and subtracting fractions. Now, here's a quicker way we can do it, finding the least common denominator. Basically, it's using the smallest common denominator we could find instead of just multiplying both of our bottom numbers or numerators together. So for this one, I'm just going to list out the LCD for 15 and 20. I'll type this one out because it might be a little bit quicker to do that so that way. So when I list these out, I'm basically just listing out all the multiples of 15 and 20, and then I'm going to circle the least one that they have in common. All right. So when I list out the multiples of 15, I have 15, like 15 times 1, 15 times 2 is going to give me 30. 50 times 3 is going to give me 45. So I'm just listing out all the multiples of 15. 75, 90. That's far enough. And then I'm going to do the same for 20. Just list out all the multiples for 20. So I have 20, 40, 60. And I can stop right there because look, I just found a common multiple between the two. Oops. Let me see if it'll let me circle it, which is 60 and 60. And that's the lowest one that they have in common. So the LCD of 15 and 20 is going to be 60. Okay. And that's how we find our least common denominators. And I'll do an example in one of the exercises of how I could sit there and add or subtract fractions, finding the least common denominator versus the way I did it for these two examples up here. Sorry, I've been sick lately, so my voice is a little scratchy. All right, so multiplying fractions. Multiplying fractions is one of the most basic ways of doing fractions. All you're going to do is multiply across. You multiply both your numerators together. You multiply both your denominators together. We're going to do an example like that once I sit there and jump into the exercises. And when we're dividing fractions, that one gets a little bit different. So basically what we're going to do to the second fraction is we just flip it and multiply it, okay? So I'm just going to set up what we would do here. So for this one, I would have 2 over 3. And this division sign is going to turn into multiplication. And I flip my second fraction. So instead of 5 over 7, I put 7 over 5. Okay. And then I just multiply across. So this is 15. 3 times 5 is 15. 2 times 7, that's going to give me 14. Okay. That's how we divide fractions. Just have to remember to flip your second fraction and change your sign from division to multiplication. We're also going to be setting up ratio problems, okay? For ratio problems, order does matter. So this one, they say 3 parts of flour and 2 parts of milk. Remember, we're going to just write that as a ratio. We can write it as 3 to 2, where 3 indicates my parts of flour and 2 indicates my parts of milk. Or I can sit there and write it as 3 over 2 as a fraction. So for example, if I had to set this up and they said, if they give me 21 parts of flour, how much milk am I going to need? I know my top half is going to be milk or flour. So they give me my flour, but they don't give me my milk, and I would have to solve for that. And I could use cross multiplication from here. But again, I'm going to sit there and show you a problem in our problem set of how we would solve this. If you did want to go on and solve this, you would use cross multiplication, get 3x equals 21 times 2, and then solve for x. Down here is more like a memorization thing. A lot of people haven't seen this a lot in math, but this is direct and inverse variation. The things I would remember, this is kind of like a memorization thing, is directly would be y equals k times x, where k is just a non-zero constant. And just remember your y decreases when your x increases. Again, we'll do example problems, and this will make a little bit more sense when we do an example problem. And then another thing to remember is inversely. Y equals k over x. y equals k over x, where k is a constant and non-zero constant. And for this one, y increases when x decreases. But again, we'll do an example with variation to sit there and see what those look like. All right. So for this video, I'm just going to do problems 1 through 9, I believe. I will make some other videos doing the rest of the problem sets because I think it goes all the way to, yeah, I think there's 29 problems on here. So I'll make 2 other videos with the other problems. But first, let's start with this first set from 1 to 9. You zoom in so we can see 1. All right, so for 1, it says, what is the value of 7 over 10 minus 5 over 12? For this one, we are just subtracting fractions. An easy way to do this is we find the least common denominator. If I sit there and list out all the multiples of 10 and all the multiples of 12, okay, I'm doing this a different way than I did the examples. So if I list out all my multiples of 10, 10, 20, 30, 40, 50, 60, and then some 12, 12 would be 12, 24, 12, 24, 36, 48. And just listing out multiples, right? Because 48 plus 12 would sit there and give me 60. And I could keep on going on and on and on. But notice with 10, I can do 10, 20, 30. Oops, sorry, that's ugly. 30, 40, and 50. And then 10 times 6 is going to give me 60. I just found that least common multiple between the two. It's going to be 60. Okay. So now I know my denominator between the two. My least common denominator is going to be 60. But now I want to sit there and see what I multiplied the bottom by to get that 60. Because whatever I do to the bottom, I have to do to the top. All right. So I multiplied this by 6 to get 60. So whatever I do to the bottom, I have to do to the top. Let's multiply that 6 times that 7. Okay. Excuse me. 6 times 7, that's going to give me 42. This 12, 1, 2, 3, 4, 5. I multiplied it by 5 to get to 60. So what I sit there and do to the bottom, I have to do the top. 5 times 5 is going to give me 25. Now that I have the same denominator, I can go ahead and just subtract both my numerators. I'm going to get 17 over 60. Okay. And that's going to be the answer is C. So I just solved that by using least common denominator. For 2, I'll sit there and use, yeah, I think I'll use this again because least common denominator is easier to use when you're using a group of fractions. So let's find the least common denominator. So to find the least common denominator of 10, 12, and 42, again, you would sit there and list out their multiples until you sit there and find which one they have in common. For this one, the least common denominator of these ones, just for time of the video, I'm not going to list out all their multiples, but on your own, you should list out all the multiples of 10, 12, and 42 and see if you can find the least common denominator on your own. But the least common denominator for this one is going to be 420. Okay. And so that means that I know that 420 will be the least common denominator for all 3. Now I just have to sit there and figure out what I multiplied the bottom ones by to get 420 and do the same to my numerators to see what number I get up top. Okay. I just finished writing this one out. Okay. All right. So to get to 420, I multiplied 10 by 42, which means I have to multiply my 7 by 42. So 42 times 7, that's going to give me 294. 12, I multiplied by 35 to get 420. So since I multiplied that 12 by 35, I have to do the same thing to the top. So 35 times 5, that's going to give me 175. $42, I multiplied 42 times 10 to get to 420. So what I do to the bottom, I have to do to the top. So 11 times 10, that's going to give me 110. Okay. Now that my fractions all have the same denominator, I can go ahead and just do simple arithmetic with my numerators. So 294 plus 175 minus 110, that's going to give me 359 over 420. Another test taking strategy skill that you could have used as well if you didn't want to go that far. Notice that your denominator either way was going to be 420. So you could have just assumed that it was going to be A if you weren't sure how to go as far. Again, if you didn't know how to find least common denominator, you could simply just sit there and add these two fractions together and get the answer for that. And then sit there and take that answer and subtract it from 11 over 42. Using the fraction way that I used in the first two examples on the top. But the easiest way to tackle this would be finding your least common denominator. All right, so let's find 3. This is going to be a ratio problem. So for this one, it says Sophia sells peanuts over the internet. Her recipe is 9 peanuts. So there's 9 peanuts to 3 parts of cashews. Okay, 3 parts of cashews. All right, and I'll annotate these. These are P for peanuts, C for cashews, and I'm just writing them as ratios. And then 1 part pecans, 1 part, and I'll put PE for pecans. Okay. How many pounds of cashews are needed to, and we'll sit there and say all together how many nuts these are. So 9, 10, 11, 12, 13, I believe. It's equals to 13 in her mixed bag. All right. So now they said how many pounds of cashews are needed to prepare 195 pounds of mixed nuts. So for this one, we need to find our cashews, this one. But just for showing purposes, I could show you like how we would find the rest of them anyways. So from here, I want to sit there and see how I got from 13 to 195. What did I multiply 13 by to get to 195? So if you sit there and take 195 and divide it by 13, you'll see that 13 times 15 will get you to 195. So I wanted to sit there and do that to each one of these. I need to multiply my 1 times 15 to get to here. So 1 times 15 is 15. So that means I would have 15 pecans. For cashews, I need to sit there and multiply 3 times 15 to get from here to here. So 3 times 15, that'll give me 45. Okay. And I would do the same for here to find my peanuts. 9 times 15. That would give me 135. Okay. So the answer here would be C because we were looking for cashews. And that's how you would set up your ratio problems. Just kind of sit there and see how you get from one ratio to the other. Like, what did I multiply that 13 by to get to 195? And that's mostly how they work. Okay. So let's go on to number 4. Number 4 is what is the value of 3 over 5 divided by negative 5 over 12. So remember with division, we want to sit there and change our sign to multiplication and flip our second fraction or find the reciprocal of our second fraction. So let's go ahead and do that. So I have 3 over 5 and then times 12 over negative 5. Just going to make the negative stay with the 5 for now. So see how I flipped it and changed my sign to multiplication. Then I'm just going to sit there and multiply across. 3 times 12 is going to give me 36. 5 times -5 is going to give me -25. B is going to be our answer, even though my negative, they made it belong to the 36. I can make once I have my fraction like this, I can make this negative belong to the top, or I can make it belong to the bottom. It doesn't matter. Okay. Whatever one you choose. So the answer for 4 is going to be B. 5, we're simplifying down. Now this is where we want to sit there and keep the logic of multiplying fractions. Okay. So the common denominator for this one, let's multiply our denominators together and then use the cross method, just like I did in those examples. So when we multiply our denominators together, I'm just going to put parentheses right now just to be safe. 5x squared. 5x squared. Multiplied by 25. xy. X. Y. Right? And that's my common denominator. For right now, I'm just going to write it all over one because I want to save a little bit of time. Then I sit there and cross multiply these two. So I would have 3 times 5x squared. Right? And then I cross multiply this way. 2 times 25xy. Remember, we're subtracting these. 2 times 25xy. xy. And put that minus right there. I'm running out a little bit of room, but that's okay. Now I would just want to sit there and simplify this down. I can distribute this 2 across. So 2 times 25, that's going to give me 50. xy. Minus 5, 10, 50, 15x squared. Oops. X squared. And this is all over. Again, I'm just combining my like terms. So I do 5 times 25. That's going to give me 125. 125. And then I multiply my x's. Now this is like an exponent rule. Like when I have x squared times x, and we will look at exponents later in the chapters. It's always an imaginary one there. When I'm multiplying two like bases, okay, I add their exponents. So this would be x to the third. And then just y. Okay. So now we're going to use a little bit of factoring. I want to sit there and see what I can pull out of my top expression. 50 and 5 have 5 in common. And then I can also pull out an x for my expression because there's an x in here and there's an x with this term. So if I pull out 5, again, if you're not comfortable with factoring, we are going to have a whole chapter on factoring. 5. And then what's left over is 10xy. Oh, sorry, I forgot to pull out the x. 5x. What's left over is 10 y minus 3x. Okay. And you know that we factored out right, because if I sit there and distributed this back through, I would get the same expression up here. Okay, if you're not comfortable with factoring, I'll do another video on factoring or provide more information on factoring. Okay. And then I can also pull out a 5x from the bottom. I pull out a 5x from the bottom. I'm going to get 25x squared. Squared y. And since I did that, since both these expressions are being multiplied, I can cross out my 5x's. And then I'm left with 10y minus 3x. And then 25x squared over y. So our answer is going to be D. Okay, that one dealt with a lot of factoring and then also knowing your exponential properties. And again, like I said, if you have questions on those, put something down in the comment. I'll make another video or show you other resources for going over those things again. So now let's look at 6. For this one, they want us to simplify. Again, we have to multiply out or multiply both our denominators together and then do our cross method. So let's go ahead and do that. So when I multiply both my denominators together, I get 1 minus x. X. Okay. Times 1 minus y. Right, that's my common denominator. And then I know on the top, I just have to sit there and subtract when I cross multiply, right? So when I cross multiply this, I have y multiplied by 1 minus x. And then when I cross multiply this way, I have x, x times 1 minus y. Oh, my mouse is acting up, sorry. 1 minus y. We'll just make a y like that. Sorry, my mouse. All right, so after we sit there and do that out, now for this portion, let's deal with the bottom four first. Again, we're going to do something called FOIL, first, outer, inner, last. Again, if you're not familiar with FOIL, write in the comments and I could sit there and show you more information on where to look up how to FOIL. But I'm going to show you how I FOIL right now. Okay, if you need more practice with it, like I said, put it in the comments. So now I have 1 in parentheses, 1 minus y, because what I do, how I FOIL, is I just take my first term, multiply it by all of my second binomial, and then take my second term, which is minus x, and multiply it by all of my second binomial. I know some people FOIL a different way, but if you do, that's fine, as long as you come up with the same answer. All right, so then I distribute this through. 1 times 1 is 1. 1 times y is y minus x. Okay, and then plus xy. That's my new denominator. Okay. Now, again, test taking strategies. If you know this is going to be our final denominator, you can look and see like, hey, this looks like what I just got as my final denominator, just written in a second way. So like if you wanted to guess, you could be like, okay, I think it's going to be D, but I'm going to show you the whole way out. Okay, just so we can make sure it's D. But if you are in a test and you're running out of time or like you're not sure how to proceed, you could sit there and look in a test taking strategy saying like, okay, this denominator looks like what I got. Let me go with this answer, but let's finish it all out. So then I would sit there and divide or distribute up top as well. So then I have x minus xy. And then minus, I'm going to put parentheses around here because that's a minus. We're going to have to distribute it through y. All I'm doing is distributing this through here. Y times 1 is y. Y times negative x is negative xy. Y. And this is all over my denominator that we just found. And I can write it in this form too, but let's just keep it how we have it right now. Minus y minus x plus xy. Okay. Now I distribute this through. Okay. So now I have x minus xy. minus y plus xy. We had to remember to distribute that negative through. That's like part of the key of this problem. Okay. These cancel out. So that means I would have x minus y over my denominator. And I can write it like them because like xy is positive. That's fine. Negative x, I have a negative x, I have a negative y, and that one is positive. They just decided to write it differently, which is fine. Plus 1. So our answer would be D. Okay. And this is our final answer. Okay. That was more of like a tricky one. So there's a lot of steps for that one. And like I said, the key one for this one is to know how to FOIL. All right, let's do 7. We have 3 more. Let's do 7. We're multiplying fractions. So when we multiply fractions, we just multiply across. We multiply across and we have our variables. We just multiply our like variables, right? So we do 5 times 6. 5 times 6, that's going to give me 5, 10, 15, 20, 25, 30. X squared. Can't really combine that with y squared. They're not the same variable, but I just write them next to each other because they're being multiplied. And then we multiply across with our denominators. 3 times 8 are constants. I can combine those, so I multiply them. All right. 3 times 8, I'm going to get 24. And then just xy. And then xy. Now, again, we are getting to another portion where we're dealing with exponential properties, okay? First, let's deal with our constants, 20 and 34. I can sit there and reduce 20 or 30 and 24 down to 5 over 4 because I can pull out a 3, which will make it 10 over 8. And then I can pull out a 2, which will make it 5 over 4. That's just reducing fractions. Again, if you need more help reducing fractions, let me know. I just have to hurry up because of the time on this video. So my constants reduced down to 5 over 4. Now, look, I have both the x right here and the x right here. When I have x's and they're being divided, this is another one, okay? This is called the exponential laws. Since I have a 2 up here and there's always that imaginary 1, what I do is I subtract my exponents, okay? So this would be x to the 2 minus 1. I subtract my exponents. Remember when we multiplied them, we added our exponents. When we divide them, we subtract our exponents, okay? And so that would be the same thing with the y. 2 minus that imaginary 1, I get y. 2 minus 1. Okay. 2 minus 1 is just 1. So then I get 5 over 4 xy, or 5xy over 4. So our answer would be D. Okay. And this has to deal with exponential rules. If you want another video on exponential rules to break it down, let me know. Put it in the comments. This one is the same thing, except we're dividing it. Remember, when we divide, we multiply and flip our signs. No, we multiply and then flip our second fraction. So this would become 5x squared over 3y times 8x over 6y squared. And I just flipped it. That's all I did. Now we multiply across 5, 10, 15, 20, 25, 30, 35, 40. Okay. That's our constants, 5 times 8. Now remember another exponent law, x squared times x, okay? And when we do that, we add our exponents. So this would be 2 plus 1 exponential laws, right? And then again, multiply 3 times 6. 3 times 6, I'm going to get 18. Multiplying like bases, okay? So that's y. 1 plus 2. So again, I simplify this down. If I do 40 over 18, I can pull out a 2. 40 divided by 2 is 20. Okay, and that's x to the third. 18 divided by 2 is 9, and that's y to the third. And I stop there because I can't sit there and combine these variables because my bases are different. So my answer is going to be D. Okay, let's do one more. This one, simplify. So this one I'm going to break apart. Let's sit there and simplify these two fractions first and then add on this one. So when I sit there and subtract these, I can multiply my denominator. So I get xy. And then I do the cross multiplication, right? X times x, that's going to give me x squared. And then y times y, that's going to give me y squared. And I'm subtracting these. That's as far as I can really go. But notice now I have the same denominator if I sit there and add on this second part. Got lucky. XY. So since they have the same denominator, I can sit there and just deal with my top part, right? And again, test taking strategy. You can see that A is not going to be one of your options because look at my other denominators here. So you can use elimination. You can even use this because I know I'm not going to do any inverses. So now B, C, and D might be our answer. So let's deal with our top. So then I would get y squared minus x squared plus 3. Now I can't really factor anything out. I can't do anything, so I'm stuck here. So our answer is just simply going to be D. That was an easy one. All right. So we did that first set of problems, 1 through 9. If you do have any questions, sit there and, like I said, leave a comment below. If you like further math tutoring, please subscribe or leave me a message because I do also private math tutoring. And yeah, I will finish off doing the rest of these problem sets in later videos. Thank you guys.